Hi guys, today we are starting section 9.4, which is called Completing the Square. But before we go into that, I just kind of want to review what it is we've been working on and how all of these different sections are connected. So if we look at the table, we see 5 different methods for solving quadratic equations. And in that box in the right corner, you can remind yourself of what a quadratic equation is. You guys learned factoring. This was actually when we were still together in the classroom in chapter 7. Um, we learned how to solve by graphing, which you guys did last week and then in the earlier chapter 8. We also covered using square roots, which is a different method. And then today, what we're covering is completing the square, and then later this week, we'll learn the quadratic formula. So, 5 different methods, and they're all used for the same thing. What our goal is to be able to solve the quadratic equation. So, I just kind of wanted to clarify that so you guys could see how everything is connected and where we're headed within this chapter. So, like I said, in section 9.4, we're going to talk about a new strategy, which is called completing the square. So this is used when we have an expression in the form of x squared plus bx. What we'll do is we'll add a specific constant, a specific number, c, so that x squared plus bx plus c is a perfect square trinomial. Now there are 3 steps, and I'm going to walk you guys through these in the example to follow, but you might want to write this down. Step 1 is to find half of b, or b divided by 2. Step 2 is to square the result from step 1, which is basically b divided by 2 squared. And then your last step is to add that result from step 2 to the expression. And that whatever that number is what your c value is, what your constant is. So if we look at example 1, it asks us to complete the square and then factor the trinomial. And the expression I'm given is x squared plus 6x. So I drew a visual just to kind of help you see the steps that we're going to be doing and why this makes sense mathematically. But for now, we're just starting with x squared plus 6x. So if you recall, step 1 is to find half of b. So I've gone ahead and labeled a and b in my expression. And our first step is to take that 6, which is the value of b, and find half of it. So b divided by 2. And essentially what this does is it takes that 6x term and we're splitting it in half so that we have 2 parts that are equal to 3x. So half of b is 3. So to see this rearranged, the reason that this strategy is called completing the square is that we're going to rearrange that x term, the 6x, so that I can make a perfect square. So I've rearranged it and I have to figure out what constant is going to go in that yellow box. So by looking at this picture, we would know, okay, well, to figure out the area of that yellow box, I need to multiply 3 times 3, which explains the reason why we're going to take half of b and then square that number that we got from step 1 in our next step, step 2. So, like I said, our second step is to square the result from step 1. So in step 1, we got the number 3. Step 2, we're going to take 3 squared, which will give us 9. And 9 is that constant that is going to complete the square. Our final step in completing the square is to add the result from step 2 to the expression. So I'm going to add 9 to my original expression, which was x squared plus 6x. And as you can see in the picture, I have now completed the square with that last constant term. That number 9 completes the square. It's a perfect square trinomial now. So the final step in this problem, it asks us to complete the square, which we've done. Now we want to factor the trinomial. So we have a perfect square trinomial because 3 squared is 9 and 3 plus 3 is 6. So we represent that as the quantity of x plus 3 squared. We have now completed the square and also factored the trinomial. All right, in our second example, letter B, we have x squared minus 9x. I'm going to just go through this mathematically instead of showing the pictures, but if we wanted to, we could still draw that area model using the rectangles to represent this problem. So if you recall, step 1 is to find half of b. In this case, b is negative 9, so I'm going to take negative 9 divided by 2, and I'm actually just going to leave it as an improper fraction as negative 9 halves. I do not want you converting your fractions into mixed numbers. So moving forward, we will leave all fractions left as improper fractions instead of rewriting as mixed numbers. After that, step 2 is to square the result from step 1. So I'm going to square -9/2, which gives me the fraction 81/4. And again, I'm leaving it as an improper fraction and I'm not converting that into a decimal or a mixed number. Step 3 of completing the square is to add the result from step 2 to your original expression. So instead of leaving it as x squared minus 9x, we're going to add that constant term. And to complete the square, we have x squared minus 9x plus 81/4. Now remember, the original problem did ask us to factor the trinomial. So to factor, I do have a perfect square trinomial. I'm going to rewrite it as x minus 9/2 squared. And that would be my final answer for this problem. So here are your monitoring progress problems. There are 3 problems for you to try. Go ahead and pause the video, try them out, and then I will show you the correct work and the correct answers for you to check. All right, so at this point, you might want to pause again just to kind of view the work that I showed. But the final answer to number 1 is the quantity of x plus 5 squared. The final answer of number 2 is the quantity of x minus 2 squared. And the final answer to number 3 is the quantity of x plus 7/2 squared.